Hello, this is the last lesson of the course. In this short lesson, we are going to briefly go over the final project and talk about an idea called bias. So the details of the final project are described in the syllabus, but here's the four basic steps. First, we're going to make a claim about a population, and then we are going to choose a sample and collect appropriate data. And then we're going to use that data in an appropriate hypothesis test to test our claim. And then we're going to write up your results in a short project. So once you get done with steps 1 and 2, steps 3 and 4 are going to be just like a homework problem. And so let's just take a step back and look at the broad overview of what we've been doing in this class, and specifically since Chapter 8. In statistics, we want to know something about a large population. For instance, maybe we want to know the population mean. Well, in order to know that value exactly, I'd have to go out and get information from every single member of my population. Well, that's virtually impossible to do. So instead, we go out and we get information from a small sample of the population. And then we calculate like the sample mean and the sample size, sample standard deviation, sample proportion, or whatever is appropriate. And those are what we call descriptive statistics. And then we use those descriptive statistics in an appropriate hypothesis test to make some conclusions about my large population. And overall, this process is what we call statistical inference, or inferential statistics. So that's what we're doing. We want to know something about a large population. We go out and we get information from a sample, and we use that to make a conclusion about our population. So the first step in your project is going to be make a claim about a population. And so we need to, there's two things involved here. First of all, we need to make a claim involving some sort of population parameter, like a population mean or a population proportion or something to that effect. And then we also need to identify what the population is. So let's look at a couple of examples of claims and identifying their populations. So here's a claim. The mean weight of all CUNE students is greater than 150 pounds. Well, what we're making a claim about is all CUNE students. And so that's my population. Now that's important to identify what the population is, because then I realize that I need to get a sample of all CUNE students. So let's look at another claim. Very similar. The mean weight of all college students is greater than 150 pounds. Now this looks very similar to the previous problem, or previous claim, except that now here we're making a claim about all college students, not just CUNE students. And so our population is all college students, not just all CUNE students. And so in order to test this claim, the second claim, I would need to go out and get a sample of all college students, not just CUNE students. Let's look at a couple of more examples of this. Here's a claim involving a proportion. More than half of all M&Ms are blue. Now when we see the word half, that means 50%, which means we're talking about a proportion. So this is a claim about a population proportion. Specifically, we're making a claim about all M&Ms. And so that's our population, all M&Ms. So in order to test this claim, I would need to go out and get a sample of all M&Ms. Here's another example. A higher proportion of male students play video games regularly than female students. And so here we are going to compare the proportion of male students who play video games regularly to the proportion of female students who play video games regularly. So we're comparing two populations. And so our populations here would be all male students and all female students. So we have two separate populations that we're wanting to compare. So in order to test this claim, I'd have to go out and get data from a sample of all male students and a sample of all female students. Okay. So that's the first step. Make a claim about your population. The claim needs to involve a population parameter, And then we also need to identify what the population is. Now, once we identify what the population is, we need to choose a sample. And as we mentioned back in Chapter 1, the goal of choosing a sample is that the sample should accurately represent the population. Now, just exactly what that means is maybe a little bit subjective. But here's a quote from the book that we should remember. If the sample data are not collected in an appropriate way, the data may be so completely useless that no amount of statistical torturing can salvage them. So in order to get valid results from any sort of statistical analysis, we need to get a sample that accurately represents the population. Another thing we should keep in mind is that randomness was particularly important. Remember, in all of our tests, all of our hypothesis tests and formulas we used, one of our requirements is that we have a random sample. So whenever we get a sample, we need to get a random sample that accurately represents the population. Okay. Now, if the sample does not accurately represent the population, then the sample is said to be biased. So here we are basically defining what it means to be a biased sample. It's biased if it does not accurately represent the population. Now, there are lots of different ways that bias can occur, and I'm not going to talk about these here in this lesson, but I would like you to read this website here. It's very short. It gives a description of 5 different types of bias, and so I'd like you to read this over before you do the homework. Now, one of the first types of bias that it talks about is what we call selection bias. And this is typically what we mean when we say the word bias. But let's give a few examples of what we mean by selection bias. So here's one of the claims we've looked at. The mean weight of all CUNE students is greater than 150 pounds. And so we've identified our population as all Concordia students. Now, let's suppose that we went out and we got a sample of 50 football players. Well, it's not a very good sample because this does not accurately represent our population. Not everyone in our population is a football player, so this is not a very good sample. So this sample does not represent the population, so it is a biased sample. This is a very biased sample. We could not use this sample to make any conclusion about the larger population of all Concordia students. Now, if we wanted to make a claim about football players, then maybe this is a pretty good sample. But this is not a good sample if we want to make a claim about all Concordia students. Let's look at another example. A higher proportion of male students play video games regularly than female students. We've seen this one before. And we have 2 populations, all male students and all female students. And suppose that we got a sample by asking all your Facebook friends to respond to a brief survey. Well, that may sound like a pretty good sample, but problem is that your Facebook friends are not really representative of all of these 2 populations. Your Facebook friends are probably all somewhat similar to you in some way, but not everybody in this population or in these 2 populations are similar to you. So asking your Facebook friends is not a real good way of getting a sample. It's a very convenient way to get a sample. So we call it a convenient sample. But as we pointed out in Chapter 1, convenient samples are not very good. So again, this sample does not represent the population, so it is biased. Let's do one last example. Another claim that we saw before, more than half of all M&Ms are blue, and our population is all M&Ms. So suppose we get our sample by buying one large package of M&Ms from Walmart. Now, at first glance, they may seem like a pretty good sample, but remember, our population is all M&Ms. So that's like all M&Ms that are sold all over the country. But this one package of M&Ms, well, although those M&Ms were all manufactured at the same time, they were all packaged at the same time, and so that may not be very representative of the entire population. Maybe on the day that M&Ms were packaged, for whatever reason the machine was spitting out more blue M&Ms than normal, and so you've got here a sample that has more blue M&Ms than typical. Maybe something like that happened. I don't know. But just buying one bag of M&Ms is not is not the greatest sample. It may not represent the population, so again, it's biased. Now, just how biased it is may be arguable. Maybe it's not terribly biased, and for our purposes, that's not probably a big deal. But we need to realize that one package of M&Ms is not a good random sample of the entire population of all M&Ms. So there we go. That's all I wanted to talk about in this lesson. So to finish up, read this website and then complete the bias homework at Course Compass.